Now we're going to look at the IUPAC naming for aldehydes. I'm assuming that you guys already know all the prefixes, meth, eth, pro, bute, penta, hexa, all the way up to maybe number 20. So let's start with aldehydes. Aldehydes are characterized by having a carbonyl group. The carbonyl group is usually defined as CHO in its condensed form, but it can also be drawn in line angle form as this plug that I'm drawing that represents that this is going to bond to something else. This, which represents a carbon, a double bond, and an O pointing upwards. But remember, this structure, we can flip it around in different fashions depending on where we're finding the chain. So, remember, the plug with a double bond, C, and an O. What is not possible because you would be violating geometrical relationship of the bonding and electromagnetic properties of atom bonding, you can never have this shape which is in a very acute angle. It always has to be like this, okay? So let's continue. Whenever we have a hydrocarbon and we find this structure at the edges of the molecules, we're encountering an aldehyde or a carbonyl group. So if I add it here, this went from being 1, 2, 3, 4, 5, 6, 7 heptane, and we're going to rename it. The ending for the carbonyl group when we're dealing with aldehydes is Al. So I take off my E, I add the Al ending, and thus the name of this molecule is heptanol with an A at the end. Let's look at other examples. It doesn't matter how many carbons I draw. Let's see. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Let's leave it right there. If I add my double bond at the edge, I'm turning all these hydrocarbons into aldehydes. Therefore, propane becomes propane, but we take off the E, propanol. Butane becomes butanol. Pentane becomes pentanol. And hexane becomes hexanol, and so forth. Okay? Now, let's make a little bit of a more complex problem. Remember, all IUPAC naming implies that you find the longest chain starring the functional group which is more important, and then you rename everything else as a radical. So let's imagine that we have this chain 1, 2, 3, 4, 5, 6, 7, 8. And we're going to add a few things to it. Let's say here. So my longest chain is going to be how many carbons long? 8. 1, 2, 3, 4, 5, 6, 7, 8. Different from alcohols, aldehydes don't need numbers for the main chain because it's always going to be assumed that the carboxy group is going to be at position number 1. I number my chain 1, 2, 3, 4, 5, 6, 7, 8, which is my longest chain, and then everything else that I have is going to be named as a substituent. So let's color those in. And what do we get? We get first our substituents. We have at number 3 and at number 5, I have methyl. But since I have 2 methyls, because I have 2 locants, I'm going to add di. 3,5 dimethyl, and then the name of the chain, which is octane, but we substitute that ending, 3,5 dimethyl octanol.